Ever wondered why it's so difficult to detect objects in the dark, even with the latest technology? It's a common struggle for us and our gadgets. Light is essential for sight, a principle that's as true for our eyes as it is for technology. So, just as you might stumble in the dark, so too does technology. Seeing in the dark is not only about the absence of light, but about how objects absorb and reflect it. Think about it. The reason we see colors is due to this very phenomenon. An object appears red because it absorbs all other colors and reflects red. Now imagine this in a low-light scenario. With little to no light to absorb or reflect, determining the color, shape, or even the existence of an object becomes a complex puzzle. So in the dark, with little to no light to be absorbed or reflected, object detection becomes a real challenge. But fear not, for technology has found ways to see in the dark. Infrared and thermal imaging are the wizards in this game. They don't rely on light, but rather sense heat to detect objects. Picture it like this. Everything that produces heat, even emits infrared radiation, which these technologies can pick up. So they literally see the heat, not the light. It's a bit like giving our machines their very own superpower. With these technologies, we can turn night into day, at least for our machines. So, what have we learned about detecting objects in the dark? We now know the significance of light for detection, how objects absorb and reflect light, and we've explored the tech that can discern objects in the darkness. It's clear that while the dark might be tricky to navigate, technology is shedding light on the path ahead.
Hello there, I'm Avi Mandavya, and along with my teammate Aditya, we are working on a project which detects objects in low light environments. Now, talking about the project, it is involving a two-step procedure, of which the first is enhancing the low light images and the second step involves implementing the YOLO V8 model on those low light images. Now, speaking of the first step, we are working on a dataset named XDark, which is the largest publicly available dataset of low light images. So the MIRNet model, which stands for Multi-Scale Image Restoration Network Model, that model preserves the context from the low resolution low light image and projects that onto a higher resolution with spatial precision. After we have implemented the MIRNet image enhancement model, we transfer those images to the YOLO V8 model. For further explanation of the YOLO V8 model, I'll invite my friend Aditya to speak about it.
We have used YOLO V8 model in our project. YOLO V8 is you only look once, that is it detects the object in one single forward propagation pass. We have used YOLO V8 nano model that has 3.2 million parameters. We have trained our dataset on 50 epochs using NVIDIA DGX server, that is the GPU, and we got a mean average precision score of 0.702. So this is a working prototype of our project. This is the interface where you need to upload the image, and when you click on submit, you get another web page where you get the results of your original image. So first one is the original image you have entered. Second is the enhanced image. Because you have entered the dark image, it enhances the image and gives you the result. And third is the objects in the given images. So these are the three results you will be given when you upload a dark image.